C is a procedural programming language. So this is a type of structured programming based around procedure calls. So we also call these procedures functions. So another type of structured programming is called object-oriented programming, or OOP. Now this is where kind of C++ comes in, because C++ is this object-oriented extension of C. So it's not possible to do object-oriented programming with C, but the C language is extended to make object-oriented programming possible, and this is what C++ is. So with object-oriented programming, instead of using functions to structure code, we instead use classes. So a class contains both data, so normally in the form of variables, and functions. But you just need to be aware, in an object-oriented programming language, a function is usually called a method. And then, so you've got this class, it contains both data and methods. And then when you create an instance of this class, this is what we call an object. So this is where the word object-oriented comes from. So we've seen that every C or C++ program begins execution in the main function. And when we're writing very short code, there's some simple example code, we normally just put the few lines into the main function. And this works fine. But generally in real life, when you're working on a project, it tends to be much bigger, much larger. It could be hundreds, thousands, tens of thousands of lines of code. And you're not going to stick all that into the main function. So instead, this is where this kind of structuring comes from, and we split our code into multiple functions. So the kind of functions are split by functionality, hence the kind of name. So each function typically handles a specific task. And then another benefit is that we can develop an individual function, test this individual function. And then once we know that's working, we can kind of treat it like a black box, and we know the function's been developed and tested and it works. So this makes it easier to debug our code and also maintain it. So the use of structured programming techniques is good practice, and it helps you to write better code. So in this flowchart here, we can see what happens when we call a function. So this will be the kind of our main function, if you will. So the code will start executing. It might execute several lines of code, and then we'll get to this function call. So when you draw a function in a flowchart, you can see we've got these little rectangles on the side. So this is just representing a function. So when we call this function, we actually jump to a different branch, if you will, in the flowchart. So we'll jump to this branch, and then we'll go through this function here, executing all the lines of code in that function. When we get to the end of the function, we'll then jump back and carry on executing code in the main function. So if we look, so this will be executed first. We'll get to this function, then we'll go 2, 3, 4, jump back 5. So this is enables us to split our code up into multiple functions, and each function is just smaller, then it's easier to write, easier to debug, easier to test. So when you're writing a function in C, the general format is below. So we've got 3 types. We've got the first part is a return type, the next part is the name of the function, and then the name is followed by this part in brackets. So this is where we've got this list of arguments. So when we call a function, we can also pass data to the function. So we'll see later we're going to write a function to do some calculations on a circle. So for example, if you've got a function to calculate the area of a circle, you'll need to pass the radius of that circle to the function. So the function then carries out some task and returns data back to the calling function. So this return type, this tells us what type of variable it is being returned. So for example, if you're with this function to calculate the area of a circle, you'll pass the radius to the function, and then the function will calculate the area, and it's probably going to be a float. It's going to be it's not going to be an integer. So it return a float variable back, what will contain the area of that circle. Now, actually, both these arguments and the return type are optional, because sometimes we might not need to send any data to the function, and then sometimes the function may not need to return anything. So in those cases, if you don't have any, if you're not returning anything, you've got this void keyword. So instead of having a return type, we would write void, and you can put void into the brackets, or you can leave them empty to say that we've not got any data that we're passing to the function. So look now at function prototypes. So when we create functions, we need to declare them using what we call this prototype, and this basically defines the interface of the function. So it tells us what the arguments to that function are and what the return type here. So we'll look at this one first. So I've just got void my function. So this function, we can see that the brackets here are empty. So that means we're not sending any data to this function, and then the fact that this return type is void means we're not returning anything. So that's one prototype. And the next one, we've got int, and this function is called another function, and then we've got the brackets. So we can see we've actually got two arguments here. So the first argument is a, and this is an integer, and comma int b. So we've got two arguments, both of them integers. We've called them a and b. So in this function, we send two integers to it. It'll do some calculation on those integers, and then it'll return an integer back to the main function. And then similar, here we've got another, well, I've called it yet another function. So this now, the return type is a float, and we're just going to pass a single float to this function. So we're going to pass a variable x to that function, do some operation inside of the function, and then return a floating point value. So at the top of your code, you tend to put the function prototypes at the top. So we've got a list of prototypes here, and you can see each one of these ends with a semicolon. So when you do the prototype, you need to include the semicolon. Then we've got our main function, so this will contain all the lines of code. And then now we've actually got the implementation of these functions. So this, you can see this part is just exactly the same as this one here, except we've not got the semicolon now. So there's no semicolon here, and then we've got open curly braces and closing curly braces. So everything, the lines of code belonging to that function will be inside here, and the same for these others. So the function prototype, is basically exactly the same as you write here without the semicolon. And in fact, when I'm writing the code, I normally type out the function prototype, then I'll just copy and paste it down here, and just delete the semicolon and add in the brackets. So that just makes sure that because these need to be exactly the same. If you type in differently, the code won't work. So it's easier just to copy and paste them. So we'll look at some example here. So we're going to do some printing, so I need to include the IO library, and I've got a function prototype here. So this is a useless function, so I've given it a useful name and called it useless function. So in our main program then, instead of executing any code in main, we're just immediately going to call this function. So this is how we call that function. We just type the name of the function with the semicolon in place. So the code will then jump to here and execute the code inside of this function. So this is the implementation of the function. You can see it just prints hello world to the screen. So it's not very useful, but it highlights how we do the function prototype, how we call a function, and then how we have to implement the function. So when we execute that, we'll just get hello world printed in the terminal. So a bit more of a complicated example now. So this function called max, so here we can pass two values to it, int a and int b, and it's going to return a single integer. So this is going to return the biggest value out of a and b. So you can see the code will start running in main, so the first line it'll execute is this, so line printf, and we can see then when we run it in terminal, that gets printed here. And then in the next line, if you remember, the assignment operator works right to left. So this is the code what's going to get executed first. So here we're calling this max function, and we're going to pass the values 8 and 4 to it. So we're going to jump to this function down here. So we can see A is going to have a value 8, B will have a value 4. So when we start executing this, this will be the second line to get executed in the max function. So this is why it appears here. Then we're going to do if A is greater than B. So we can see here A greater than B. Yes, it is. 8 obviously bigger than 4. So then we'll return A. So that'll be executed then, and we'll jump back to here. So when we return, it's going to have to the value A will be returned. This is this integer data type because A is an integer. This is why that's an int. So it's going to return this integer to here, which is then going to be stored in an integer variable we've created. So the value contained in A, so in this case 8, will be stored in this variable biggest. So that's the kind of next bit of code that's executed. And the last bit is this print statement. So we'll print the biggest equals, and we'll just print the value that's stored in that biggest variable. So this is where we're passing values to a function, and then when we return values from a function, we tend to store them in a variable, so that'll get stored in this variable here. Again, a bit more of a more complicated example. So here, this is where we're going to do some operations on a circle. So because we're going to need pi, I've created this preprocessor directive using the define statement. So now every time pi appears in our source code, the preprocessor, before we compile it, the preprocessor will replace all instances of pi with this number here. And I'll just put f at the end just to enforce the fact that it's a floating point number. So you can see, and then we've got our 3 prototypes here. So all of them, we're passing the radius to that function. So we've got functions for calculating the area, diameter, circumference. And then all these instances, we're going to be returning a float as well. So they're the function prototypes. So when we run this code, the first line of code in main, we're going to set the value, the variable called radius, to have a value of 1.5. And then we're going to call this function get circle area. So get circle area, and I'm going to pass the value radius to that function. So this then will go to this function here, and then the circle area is obviously pi r squared. So I'm going to return pi times radius times radius. We could have done that, we could have done float area. So we could have created a variable in here and done pi times radius, and then I could have done just return area. However, you can also, rather than creating a variable we don't really need, for this simple example, we can just return that value directly. So it'll do pi times radius, return this to here, which then will get stored in the variable we called area. And essentially the same for the diameter. So in this line, we're going to call the get circle diameter function, and again pass in the value of the radius. So that'll jump to here, and it's just going to return 2r essentially. So obviously know the diameter is just 2r, and that'll get stored in this variable here, diameter. And then same thing again, get circle circumference, pass in the radius. That'll then jump to this part of the code. That value be stored in radius. We'll do 2 pi times radius. Depending on the compat, really I probably should have put 2.0 here. just to ensure that the compiler uses a floating point rather than an integer. That'll get returned and store it in circumference. So you can see here, just split the code up into these functions for calculating circle area, circle diameter, circle circumference. So as well as writing our own functions, we can also use functions that are part of the C standard library. So we do that by including the relevant header file. So we've already seen, we know printf is essentially a function part of this standard library. What's included in stdio, the standard input-output library. There's lots of mathematical functions, sine, cos, tan, exponential and so on. And these are in this CMath library. And there's also other libraries that are available, so you can find reference to these online. There's various websites you can find. So in this example, we'll look how to use a CMath library. So at the top here, I'm going to include CMath. And again, we're going to do some trigonometry. So we need the value of pi. So I've created this preprocessor directive here, defined pi to be equal to its value. And I've also defined what we call a macro. So here I've got this name deg2rad. And then instead of typing a value, I've actually just got a very simple expression here. So pi divided by 180. This is going to convert essentially degrees to radians. So every time we have the word deg2rad in our code, you'll actually get replaced by this scaling factor we need to convert degrees to radians. Because trigonometric functions in C and C++ use radians rather than degrees. So in this example here, so now we define these in the main. I've created a variable called x. So x is essentially 45 degrees. But I need to, if I multiply it by deg2rad, it'll convert that to radians. So I'll just do, the preprocessor will replace this by this. So x will contain 45 degrees in radians. Then we can just do float y equals sine of x. So you can see this is a sine function what's declared in CMath. So we just got a single argument here. We're just passing x, and then it'll store the result in y. So the next line will just print this out. So you can see when you execute this, it's converted 45 degrees. It's printed x here, so it's converted 45 degrees to radians, and then it's printing out the value of y. So I can see here. So that's using one of the CMath libraries. Another example I'm going to use from the C standard library, and then also the time library. So this is kind of a national lottery code, so it's going to pick our lottery numbers for us. So first line, print lucky dip, so this is why that prints here. And then the srand function, this is where we seed the random number generator. So essentially, it's impossible essentially to create random numbers, truly random numbers. And if you just, with the computer, if you create random numbers that create the same ones every time. And so to make sure you get different random numbers, you need to seed the random number generator with a different value. So srand is part of the C standard library. So to seed the random number generator, I'm actually going to use the current time. So this will return Unix time, and that's part of the C time library. So because every time you run this code, you're obviously going to run it at different times. So whichever time you run it at, this will essentially seed the random number generator with the value of Unix time. So because Unix time is obviously going to change every time you run the code, you'll get a different set of random numbers every time. And then the next bit, I'm just going to run through a for loop. So the for loop's going from 0 to 6. So I just want to repeat this 6 times to create the 6 numbers. And then each time we'll create a variable n. And I want to create a number in the range 1 to 49. So rand rand actually returns a value, a random number, starting from 0 up to a very big, 32-bit or 64-bit number. So we don't, because the lottery numbers don't start at 0, we need to add 1 to it to make sure we start at 1. And then to limit the value, this is a very common technique using the modulo operator. This is essentially a remainder. So random will give us a very big random number. And here we divide it by 49. And then the modulo returns a remainder. So we know if you divide a number by 49, the remainder is either going to be 0, 1, 2, 3, 4, up to 48. And that's the only values of remainders we can get. So we can essentially here, we've got 1 plus the random number in the range 0. So this essentially gives us a random number in the range 0 to 48. So if you add 1 to that, then we'll get 1 to 49. I'm just going to print, and we'll print that value here. So when we run the code, it's printed at these random numbers. So you can see there's actually a little bug here. I've left it in deliberately, just to show that this code's not actually smart enough to do what I want it to do. So when we run this code, we've actually ended up, it's generated 2 with the same random numbers as, this is obviously completely possible. So really, in reality, this code would have to be a bit more complicated. When you generated a random number, you'd have to check that you've not already generated that number. So this, this is demonstrating essentially we can use rand and the srand function from the C standard library, and then the time function from ctime.